So with an set, this is what the property said. The property says A intersection length set to be equal to its set. So let's try proving that. We have a set A. We have values 1, 2, 3, and it sets on the length set. Let's say B is equal to, or B is equal to length set, or the A intersection. A intersection of B will be equal to, since there is nothing which is common between this set and which is common between the values inside this set and here, the result will also be an answer. Okay, so this. So A intersection of cell will be the set. So that is the property. So we can go now to 2.3 complement of the set. Please, that's the truth now. The most also. So 2.3 complement of the set. So what is the complement of a set? If you have a universal set, let's imagine you have a universal set which is given by 1, 2, 3, 4, 5, 6, 7. Let's imagine these represent the 7 days of the week. You have a universal set comprising of the 7 days of the week. Change by letter. Let's imagine one is Monday. So it's Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So then you have your own set. This will be a subset of this universal set. It is a proper subset of the universal set. Let's imagine this is Monday, Tuesday, Wednesday, Thursday. Or this is 1, 2, 3, and 4. Like it is crazy. What is the complement of this? The complement of A represented as A complement A bar or you have A complement A bar or not A. This A complement is not A, is A prime. So you call this A complement, not A prime. They all mean the same thing. They all mean the complement of the set. So what will be that? That is equal to anything that is inside this universal set minus A. So anything that is inside the universal set that is not inside A. So every value that is in the universal set that is not in A is A complement. For instance, what is the value that is here that is not here? A complement will be equal to 1 is here and here, so you don't write it. 2 is here and here, 3 is here and here, 4 is here and here, so you don't write it. What is here now that is not here? You have 5, 6, and 7. So right here you have 5, 6, and you have 7. So you will see now that A complement is the values of epsilon or zeta I mean, which are not found in A. where zeta is your universal cell. So you always look for the universal cell and remove that A from it. So you subtract the A from it. If you do your normal subtraction, you're going to see that if there's 1 here and there's 1 here, so you remove it, you subtract it. So there's 2 and 2, so you subtract it. Here there's 3 and 3, you subtract it. Here there's 4 and 4, you also subtract it. If you subtract this, you'll be left with 5, 6, and 7. You write for 5, 6, and 7. So that is what complement is all about. So, as I said, can be written like this. The complement is A complement, not the A prime. Can be written like those three. And the formula is A prime is equal to zeta minus A. And zeta minus A. Alright, so example 1. Example 1 says zeta example 1 says zeta equals zeta. Our zeta is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our A is 1, 2, 3, 4, 5. What will be our A prime? A prime is any value which is here, which is not here. Okay. A prime is every value which is here, which is not here. We can write your formula and zeta minus K is equal to 1 is here, 2 is here, 3 is here, 4 is here, 5 is here. So it is 6, 7, 8, 9, and 10, because from 6 to 10 are the values which are in our universal cell and zeta, which are not in A. That is our A prime. So yes, that is it. So I can have this and now have my A as S. So that S is a prime number in between 0 and 10. So what is A complement? Voila. Now I would like you to go and do this exercise. Try doing this exercise, find a complement, then come and find it. So another table given is what? Zeta minus O. What is my A? A in the listing form. A in the listing form is what? You said it is X, such that X is a prime number in 2, 0, and 10. So X is a prime number in 2, 0, and 10. Prime numbers 2, 0, and 10 are 1, 2, 3, 4, 5, 6, 7. Oh, prime numbers. Prime numbers in 2, 0, and 10 are 1, 2, 3, 5, and 7. So this is 10. This is 8. So what will be A prime? And implies A prime is equal to every number that is here that is not so fine. I'm not found there. It's 1 here and here, so 1 is not there. 2 is here and here, so it's not there. 3 is here and there, so 3 is not there. 4 is here, but 4 is from here. It's not here. So you write your 4. There's 5 here, there's also 5 here, you can write it. 6 is here, 6 is not here, so write your 6. There's 7 here and here, you don't write it. 8, 9, and 10 are there and not here. So you write your 8, 9, 10. This is going to be your A prime. So that is it for the complement of a set. So now you know what the complement of the set is. Analogically, it can also represent the contrary of a set. Like when you're going to do binary digits, binary numbers. Yeah, when I'm going to do binary numbers, I'm going to say complements. Digital electronics, Boolean algebra. We're going to say complements. Properties. So what is the first property? The first property says double complement. The double complement property. Double complement is either A prime or prime is equal to A. So if you have A prime, all other prime will give you A. Shall we prove it? Let's try proving it here. And let's imagine we have our antizeta 1 to 5. Our antizeta is 1 to 5. And our A is just 1, 2, and 3. So let's find A prime prime and see if it is the same as A. So to find A prime all our prime. So let's find A prime. What is A prime? A prime is all of the values that are here that are not here. So it is antizeta minus this A. What is going to be? We're going to have 1 is here and here, so you don't write it. 2 is here and here, so you don't write it. 3 is here and here, so you don't write it. You have 4 and 5. That is our A prime. Now we're looking for A prime prime. So what is A prime? All of that prime. A prime, all of that prime is just this thing, prime. So when we look at our antizeta, we look for every value that is here that is not found yet. But it's going to be most A prime. So you take the prime of this. So what is the prime of this? You check 1 is here. Is there 1 here? No. So you write our 1. You write numbers that are here but not here. 2 is here. Is there 2 here? No. So you write it. 3 is here. Is there 3 here? No. So you write it. 4 is here. Is there 4 here? Yes. You don't write it. 5 is here. Is there 5 here? Yes. You don't write it. So this is A prime. And then you can see that your A prime all prime is the same like your actual A. So this law is fulfilled. Because these are the same. Alright. So let's do the next property. The next property is union complement. It states that A union A prime is equal to your antizeta, where antizeta is a universal set. So let's keep all this out. Let's check if that is correct. We have our A. We have our antizeta as a plus 1, 2, 3, 4, 5. And we have our A as 1, 2, 3. The more is going to be our A prime. We calculated it and it was 4 and 5. Now, if you do A union A prime, we just did union before. What is A union A prime? It just means you add the values, you take the values that are here and the values that are here and put it in one set. Let's check and see if it is going to give us our antizeta here. So we're going to have 1, 2, 3, 4, and 5 because 1 is here, you add it 2, 3, you put it. Now you check 4, you put it 5, you not put it, so you put it You just test it. So, you can now see that A billion A price is actually or antecedent. Check where it looks like this. See how it. So this conclusion is true. So let's check a variable property is series. Intersection with complement. So this is linear complement. The third property says intersection with two equals and two to basic so I'll be I come start you because this is how the condensing. We are in a social complement there. Oh no. So pero tato the last bit so the complement. It says that A intersection A prime is no minor. A intersection A prime is null. So let's use our data and do an example. So you have our A and our A prime. Let's try and see what A intersection A prime is. I say if it is not. So what is the meaning of intersection again? If I say A intersection of A prime, it means what are the values are in A that are also in A prime. We need the values are in A but are also in A prime. So what are those values? P value in A here is also in the A prime. 1 is not in A prime, 2 is not there, 3 is not also there. So it is a null set. It is a null set derived by this call except it's null. It is not the way it is not this. This means it is a set which contains a null value. The null here is an element of a set. This means it is a null set, means it is a set which contains no element, zero element. Here, null is an element of the set. So, we can see that the proof is morphine. Yeah, the property I mean. So the fourth property is this one here. Discuss complement of universal set. So complement of universal set. States that the complement of the antecedent at any time C is a null matrix. And that is true. You see that if you have an antecedent like this is your zeta, where zeta is a universal set. Let's imagine this is an universal set. The complement of this universal set is nothing because if you have everything, the complement of everything is nothing. This universal set contains everything needed. The complement of it is nothing. So that is what the law is talking about. That is 1, 2, 3, 4. And the fifth and last property is a complement of this property. So it's complement of M set. Complement of M set. So what is a complement of an empty set? We have an empty set like this. Complement. Actually, everything. Exactly. Likewise, yep, a set which has nothing. This is an example of an empty set. The complement or the contrary of nothing is everything, and everything is your anticipa, which is an universal set. So that is a fifth and last law of last property, of the complement of the set. So now we'll go to difference of sets, which is just the subtraction topic. So in difference of sets, so what is the meaning of difference of sets? A minus B. Just like you did before, A minus B means elements that are in A which are not in B. Elements that are in B which are not B. Elements which are in A which are not in B. For example, you have, let's take an example, you have A is equal to 1, 2, 3, 4, 5. That is your A. And your B is 1, 2, 3. This is your B, this is your B. What is A minus B? A minus B just creates elements in A has are not found in B. So which element in A is not in? 1 is in A and B, 2 is in A and B, 3 is in A and B, 4 is in the A and not in B. Because I have 4 here. 5 is in A and not in B. There you have 5. So that is A minus B. So A minus B can be written like this, or it will be still written like this. This is A minus B. This is A difference B. Can be called this A difference B. A minus B. Right? Oh, this stroke is this way. The stroke is this way. This stroke is division. This stroke is division. This stroke is difference. Alright, so let's take an example. So if you don't know what A minus B is, the formula is A minus B is equal to A intersection B prime. So A intersection B prime, you see that? So what was our A minus B equal to here? Our A minus B was equal to 4 and 5. Let's see A intersection B prime. What is our B prime? From here, our B prime is going to be 4, 5. Our B prime is going to be 4, 5, given that our A is antitheta. Our A is our universal set. So what is A intersection B prime? A intersection B prime is your everything that is in A and that is also in B prime. It is what? We have only 4 and 5. 4 and 5 is in A and B prime, and only A. So now you see that A minus B is the same like A intersection B prime. So if you don't know what to do, you can simply leave the session with them. So let's just a few examples. And here it's not A minus B is not the same. A minus A, where we are going to see properties of the upper. I'm going to see properties of different subset. So the contrary of this A minus B, it is A plus B or A mu. So, for example, we have A 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And B is equal to 3, 4, 5, 6, 7. What is A minus B? A minus B is equal to everything that is in A, that is not B. A minus B is A intersection D prime. So everything that is in A that is not in B. In A, you see what is in A, you remove values of B from 1. Is 1 here? No. Okay, let's check B. B has 3, so we are going to remove 3 from here. B has 4, we're going to remove 4 from here. B has 5, we're going to remove 5 from here. B has 6, there's no 6 here, so don't remove it. B has 7, there's no 7 here, so don't remove it. What is left? You have 1 and 2. So A minus B is 1 and 2. It's just stay where you remove every value of B from it. What are you left in A? B, 1 and 2. So, now let's do B minus A. Suppose the vision tries B minus A, they come back and see. I like this. So now what is B minus A? B minus A means every value in B that is not in A. So inside this B, you remove everything that is in A. So you look at A, 1 of 1 here, no. 2 is 3 here, no. 3, you remove the B here, so you remove it from here. 4, the square here, you remove it from here. 5, the square here, you remove it from here. What will you be getting in B? In B, you will be left to 6 and 7. 6, 7. So when they say A minus B, you remove the things that are in common and you look at what is in A. What is in A? 1 and 2. You see, you have removed everything that is common. 3, 4, and 5 are common. What is in A? You have 1 and 2. So A minus B is 1 and 2. But what is in B? You have 6 and 7. So A minus B, B minus A, I mean 6 and 7. That is just it. So take another example. To take another example, we have A is called multiple of 3. A is equal to multiple of 3 from 1 to 20. A is equal to multiples of 3 from 1 to 20. That is the descriptive method of showing the set. But let me just show it with the normal method, like the listing method. Multiples of 3 from 1 to 20. You have 3, okay, 1, 3, 6, 9, 12, 15, 18. B is multiples of 2 from 1 to 20. Multiples. Something with 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. From 1 till 20. and they say to 20, if they don't precise exclusively, you write the 20. When they say from 1 to 20 exclusively, means don't include the boundaries. We don't include 1, we don't include 20. If they say multiples, it does not have 1. If they say factors, it start from 1. Multiples means we multiply 3 by 1, they're going to have 3. The first value is actually 3. And I'm 20. Here 20 is not a multiple, I leave it there. Here 20 is a multiple, I keep it there. The next multiple is 81, so I stop at 80. So what is A minus B? A minus B means values of A which are not in. So I cancel the common values and I check if value is in A. I'm going to find B. So 3, is it 3 here? 3 is it 3 here? No. 6, there is 6 here. 9, there is no 9 here. 12, there is 12 here. 15, there is no 15 here. 18, there is 18 here. So A minus B will be what? What is left? What is inside K like left? You have 3, 9, 15. 3, 9, 15. That is A minus B, 3, 9, 15. Now, what is B minus A? B minus A is values of B which are not in K. So when you have cancelled common values, you'll be left here with values of B which are not in A. So you have 2, 4, 8, 10, 14, 16, 20. 2, 4, 8, 10, 14, 16, 20. Where's my algorithm? 2, 4, 8, 10, 14, 16, 20. So that is B minus K. For B minus A, you just check the values of B, which are not in B. So you see it in B. For A minus B, check the values of A, which are not in B. You see it in A. Alright, do like that. So as I say, an important look, A minus B is not the same like B minus A. They're not commutative. Like union and intersection. This is not commutative. So now let's go to the properties. Properties of difference. Properties of difference. So the first one says, is it complement? This was already proving. A minus B is A intersection B compute. We proved it already. So you can simply let A equal to 1, 2, 3, 4, 5. And B equal to 1, 2, 3. A minus B, if you want to use this method, what is going to be your answer? So the values of A which are not in B. How do you need to find it? You cancel the right terms here. You have 1, 1, 2, 2, 3, 3. What is left in A? A minus B is equal to 4 and 3. That is the answer I had using this method. So let's use the complement method and see if it is the same answer. So we already have our A and our B. So it says A intersection B complement. Should also be this. So we have our A. What is B complement? I'm looking for B complement. Given our A is our antecedent. What is B complement? B complement is every value which is not found yet. Which is is every value which is not found yet. Yeah, every value in B which is not found yet in the antecedent. So what is every value in D which is not found yet? 4 and 5. I mean, every value in A which is not found here means the values are 4 and 5. So your B prime is going to be 4 and 5. So what's A intersection B prime? A intersection B prime is A intersection B prime is values in A but are also in B prime. In A, we have values like 1, 2, 3, 4, and 5. In B prime, we have just 4 and 5. So 4 is common in V prime and in A, so write there 4. And 5 is also common in B prime and in A, write there 5. So now you see that A intersection B prime is the same like A minus B. So we say this law is fulfilled. This B prime is equal to also 4 and 5, but this is just a coincidence. It will not always be the case. But A intersection B prime will always be A minus B. So that is equal to the first property. The second property says A minus A is normally equal to an intercept. If you have this B or this A, you have the same A. From it, you remove the same A. You have an intercept normally. So, what is the third property? The third property says A minus an intercept is equal to A. Normally, if you have A like this, and from it you subtract an intercept, from it you remove an intercept, A is nothing. Like when you see A minus B, it means inside A you remove B. So if B is there and B is 1, 2, 3, you just remove the 1, 2, 3 inside A. If you remove the 1, 2, 3 inside A, you will be left with 4 and 5. That's why I have it like that. So if they say A minus intercept means inside A you remove nothing, and intercept means it's a set that has nothing. So if you remove nothing from A, you are going to have the same B. So what is the next property? It is an intercept minus A. So what do you think an intercept minus A is? An intercept minus K. What is it going to be? No, it's not negative K. Yes, an intercept. Me explaining okay that per se. Now an intercept could be a set B, which is anything. If you do that intercept B minus A is equal to what? You look at B and you remove everything that is A. From this B, if you remove 1, you will get the same B. If you remove 2, you will get the same B because there's no 1 inside, there's no 2 inside. So if you remove 3, you will not affect this. You remove 4, you will not affect it. If you remove 5, you will not affect it. Because it is not inside. There is no 5 here, there is no 1, there is no 2, there is no 3, there is no 4, there is no 5. So even if you remove whatever, it is still going to be the same B. Given that B is an empty set, in this case it is going to be the same B. So an empty set minus anything, any set will give you the same empty set. So the fifth and last property, it says if B is an element of A and A, if B is an element of A, then A minus B then A minus B are elements means elements in A which are not B. So if B is an element of A, is a subset of A, then A minus B means elements of A which are not in B. Just like they are saying. If B is a subset of A, like here B is actually a subset of A minus B means element of A which are not in B. Element A minus B, this is B minus A. A minus B means elements of A which are not in B. In this case, what is B? B is an empty set. So elements A minus B will be elements of A which are not found in B. So in this case, elements of A which are not found in B is everything. You see here, elements of A is 1, 2, 3, 4, and 5. Elements of A which are not found in B is the same 1, 2, 3, 4, and 5 because B is empty. So if our B was not empty, if our B was 2, 3, 4. That law says, this law here says, given that B is the subset of A minus B is just the elements of K which are not found in A. Elements of P which are not found in A. So what are the elements of A here which are not found in this B? So 1 is found in this B. No. Right here 1. So it's 2 found in this B, yes. 3 is it found in this B, yes. 4 is found here, yes. 5 is not found here, so you write the 5 there. So in this piece, A minus B is elements of A which are not found in B. You see, as we were saying, from this here you remove B. If you remove 2 and you remove 3 and you remove 4, you'll be left with 1 and 5. Just like this. So